Increased media coverage has heightened public awareness of earthquakes worldwide. This heightened awareness has led to concerns about the frequency and intensity of seismic events. It is important to understand the causes and patterns of earthquakes to address these concerns. Analyzing seismic activity is crucial for assessing whether earthquakes are genuinely becoming more frequent. Earthquakes are mainly triggered by the movement of tectonic plates. Stress accumulates along fault lines due to this plate movement. When stress surpasses friction, a sudden energy release occurs. This released energy propagates as seismic waves. Understanding these processes is key to interpreting earthquake patterns. Geological and space technology advancements enhance seismic activity monitoring. Enhanced monitoring networks provide more comprehensive earthquake data. Satellite-based measurements improve the detection of smaller seismic events. Improved detection contributes to the perception of increased earthquake frequency. The Earth is structured into 3 primary layers with distinct compositions and properties. The outermost layer is the crust, a relatively thin and rigid shell. Beneath the crust lies the mantle, a thick layer of hot, semi-molten rock. At the Earth's center is the core, an intensely hot sphere, primarily made of molten iron and nickel. The core's outer layer is liquid, while the inner core is solid due to immense pressure. These layers dynamically interact, influencing various surface phenomena like plate tectonics and volcanism. The Earth's crust is fragmented into large tectonic plates. These plates float on the Earth's mantle. Tectonic plates are in constant motion. Plates interact at their boundaries through collision, sliding, or separation. Plate interactions are not continuous or smooth processes. Earthquakes are caused by the sudden release of accumulated pressure between tectonic plates. Pressure builds gradually over extended periods due to the movement of these plates. When the accumulated pressure surpasses the rock's strength, a rupture occurs. This rupture generates seismic waves that radiate outward from the point of origin. The propagation of these seismic waves is what we experience as an earthquake. A century ago, only major earthquakes were recorded due to technological limitations. Today, a global network of sensitive sensors detects even minor tremors. Previously undetectable events are now instantly documented and analyzed. This leads to a perception of increased earthquake frequency, despite potential consistency in actual events. Increased population density means more people are living in seismically active zones. Even minor earthquakes are now felt and reported by a larger number of people due to urbanization. This leads to a perception that earthquakes are becoming more frequent. The increased reporting is directly linked to more individuals being affected and sharing their experiences. Modern media provides immediate global dissemination of earthquake news. Even tremors in remote locations rapidly become global news. Smartphones and online platforms facilitate this real-time information spread. This instant global awareness amplifies the perception of increasing earthquake activity. However, the overall number of earthquakes may not have significantly changed. Certain fault zones are experiencing increased tectonic pressure, contributing to the perceived increase. The Pacific Ring of Fire is a horseshoe-shaped region around the Pacific Ocean. It is characterized by high levels of seismic and volcanic activity. Approximately 75% of the world's active volcanoes are located in this zone. The Ring of Fire also accounts for about 90% of the world's earthquakes. The Ring of Fire's intense geological activity is driven by the movement and interaction of tectonic plates. These plates are constantly shifting and colliding, creating zones of high stress and energy. Subduction zones are a key feature, where one plate slides beneath another. This subduction process leads to the formation of magma, fueling volcanic eruptions. The same tectonic forces also cause the buildup of stress, resulting in frequent earthquakes. Several countries along the Ring of Fire frequently experience seismic events. These countries include Japan, Indonesia, Chile, and parts of the United States. Recent scientific data indicates increased seismic pressure within the Ring of Fire. This increase in pressure may lead to more frequent earthquakes. The increased seismic activity poses a threat to vulnerable coastlines in these regions. Induced earthquakes are seismic events triggered by human activities. These activities alter the stress state of the Earth's crust. Deep mining operations can trigger induced earthquakes by removing substantial rock mass. Extensive drilling for oil and gas can also destabilize subsurface geological formations. Both mining and drilling can lead to induced seismic events. Underground fluid injection raises pore pressure in rock formations. This process is common in waste disposal and enhanced oil recovery operations. Conversely, groundwater pumping reduces pore pressure. Changes in pore pressure alter the effective stress within the subsurface. These pressure variations can lubricate faults, increasing the risk of slippage and induced seismicity. Large-scale dam construction puts significant pressure on the Earth's crust. This added weight increases stress on pre-existing geological faults beneath the dam site. The filling of the dam's reservoir introduces further pressure to the surrounding area. This increased pressure can destabilize the region, potentially activating dormant faults. Such activity may trigger seismic events, even in areas previously considered geologically stable. Scientific research suggests that the actual number of earthquakes has not significantly risen. Advancements in technology have greatly improved global seismic event detection and measurement. Enhanced detection capabilities create the impression of increased earthquake frequency. Historically, large and destructive earthquakes have occurred consistently throughout recorded history. Earth's tectonic activity is a normal geological process. Earthquakes are a result of the movement of tectonic plates. This movement has shaped the planet for billions of years. The frequency and intensity of these movements are consistent with geological trends. High population density in cities increases earthquake impact. Inadequate building codes worsen earthquake vulnerability. Poor disaster preparedness amplifies earthquake effects. Human vulnerability, not the earthquake itself, increases perceived deadliness. Investing in resilient infrastructure and emergency response is crucial. Scientific data suggests an acceleration in the movement of certain tectonic plates. This acceleration may lead to an increased frequency of earthquakes. The magnitude of earthquakes could also potentially increase in specific regions. These changes are projected to occur over the coming century. Advanced seismic sensors are used to monitor this tectonic activity. Satellite measurements provide additional insights into subsurface dynamics related to plate movement. Glacial melting decreases the load on the Earth's crust. This reduction in weight causes isostatic rebound, or the rising of land. Isostatic rebound can induce shifts in geological faults. These shifts may trigger seismic events, even in areas formerly considered stable. Therefore, ice mass loss is directly linked to crustal deformation and potential seismic activity. Rising sea levels and intense storms increase pressure on ocean floors. This pressure exerts significant stress on the Earth's crust beneath the ocean. The increased stress can potentially activate dormant faults in the seabed. Activation of these faults contributes to overall seismic instability. Ocean dynamics directly influence geological structures through pressure transfer. This phenomenon highlights the interconnectedness of oceanic and geological processes.